The topic to be discussed in this video is radio frequency identification, RFID, radio frequency identification. Radio frequency identification is the use of radio waves to read and capture information stored on a tag attached to an object. That is the definition of radio frequency identification. RFID is the use of radio waves. Radio waves, that means electromagnetic waves, to read and capture information stored on a tag attached to an object. Object is nothing but a device. This is the definition of RFID, radio frequency identification. Next, coming to second important point here is there are two major components on which the RFID technology is built, namely RFID radar, RFID tags. RFID radar and RFID tags. Host compute is also an important part. Sometimes along with these two, some host computer plus some host computer is also an important part of the RFID operation. That means maintain some computer database for storing the data. This is the definition. These are the two main major components which are used in RFID technology are RFID radar, RFID tags. See this picture. This is the basic RFID system. This one is RFID radar, RFID tag, computer database. Information is attached to RFID tag. Object information is attached to RFID tag. The communication between RFID radar and RFID tag is in the form of radio waves. Some antenna is used here, transmitting antenna and the reception antenna used in RFID radar. And also in RFID tag, some microcontrollers, rectifiers, power supply units, and some antenna transponder is also used in RFID tag. The RFID radar extract the information from the RFID tag. That information is stored in the computer database. Later I will explain individual components description: RFID radar, RFID tag, antenna. Coming to next side heading is RFID radar. RFID radar. RFID reader continuously sends radio waves of a particular frequency. This one is a RFID radar. Continuously sends. These are the radio waves. Radio waves of a particular frequency. If the object if the object on which this RFID tag is attached is within the range of RFID radio waves, then it sends the feedback to the RFID radar. Suppose an object is attached to RFID tag within the range of this radio waves to a particular frequency, the RFID radar, the RFID tag sends some feedback signal to RFID radar. In this direction, the radio waves are propagated. Here, some RFID tag is there. That RFID tag is attached to object. RFID tag is attached to object. This object within the range of this radio waves at a particular frequency. Therefore, the RFID tag send some feedback signal. Some feedback signal to RFID radar. RFID radar identifies the object. RFID radar identify the objects. Coming to components, radar components, RFID radar components. This is the microcontroller. This one is a RF signal generator. Here, some antenna is attached here. This is the transmitting antenna. Here, receiver. Received information is applied to microcontroller. The received information is collected through this antenna, receiving antenna. This is a transmitting antenna. These are some RFID radar components. Here, some connectivity is also there here. The signal generator, this is the signal generator. The signal generator is responsible for generating of radio signals, which is transmitted through this antenna. These are the signals generated by RF signal generator is transmitted through transmitting antenna. Also, the same unit as a receiver. Here, receiver is also inbuilt with this RFID radar system that receives the information signals from the tags. Receives the information signals from the tags. This is the transmitted information. This one is these are the tags. That receives the information signals from the RFID tag. Okay, the receiver also the same unit as a receiver that receives the incoming signals from the tag. The microcontroller are used for the purpose of processing the information. This is the microcontroller. These are the basic components of the RFID reader. Microcontroller, RF signal generator or receiver. Two antennas are used. One antenna is used for transmitting purpose from RFID reader to RFID tag. Another antenna is used for receiving purpose from tag to RFID reader. The received information is applied to microcontroller. The microcontroller function is processing the information. Next, second important here is RFID tags. RFID tags. Three different kinds of RFID tags are commercially available. These are passive tags. Second one is active tags. Third one is a semi passive tags. First one, passive tags. Passive tags that don't have a power source. Electromagnetic energy from the radar powers these tags. That is very, very important. Passive tags. Tags that don't have a power source. Electromagnetic energy from the radar powers these tags. With the help of RF signal generator at the RFID radar, electromagnetic waves are reached to RFID tags. With the help of these electromagnetic waves power these passive tags. Power is compulsory processing any information. Without that power, the device is in dead mode. While active tags have a power source. Next, active tags. Active tags have a power source for their internal circuitry, and for sending the response to the radar also, it uses its own power supply. That is, active tags are inbuilt with some battery power, small battery power. With the help of that small battery power, operate the circuit components and also send a feedback signal to RFID reader. Active tags have a power source for their internal circuitry. That means a small battery power. And also for sending the response to the radar, it uses this own power supply. And also for sending the response to the radar by using its own power supply. Next one, in case of semi passive tags. Semi-passive tags. In the case of semi-passive tags, they have a power supply for internal circuitry operation, but for sending the response, it receiving from the radio waves from the RFID tag. That is the important one. In the case of semi-passive tags, they have a power supply for internal circuitry operation, but for sending the response, it depends on the radio waves from the radar. Here, the components of RFID tag. This one is a transponder. This one is the antenna. Rectifier circuit. This one is controller. This one is memory. Here, coming to concentrate on transformer, this is the transponder. The transponder present in the tag receives the incoming radio waves from the radar and retransmit the feedback signal back to the radar. Receiving the information from the radar, retransmit a feedback signal to the radar. That is the main function of the transponder. The transponder present in the tag receives the incoming radio waves from the radar and retransmits the feedback signal back to the radar. This is the feedback signal. Here we can see that a rectifier circuit. Here rectifier circuit is present, which is mainly used in the case of passive tags only, not active tags, which takes the energy from its operation from the incoming electromagnetic waves. The operation of the rectifier circuit is totally depends on incoming radio waves captured by this antenna and then applied to rectifier circuit, which is rectifier circuit is generally meant for passive tags only. In such a case, the rectifier circuit helps in storing the energy. The stored energy is provided to the controller. The stored energy is provided to the controller and memory for the operation. This is the components of RFID tag. Next, coming to advantages and disadvantages of next RFID system is mainly operated in three frequencies. First one, low frequency low frequency RFID system. Low frequency RFID system. The range from the frequency range from the frequency range from 30 kHz to 500 kHz. Optical the typical frequencies, the exact frequencies, the typical frequency is 125 kHz. In between these range, select one frequency that is called as typical frequency. Generally, low frequency RFID has a short transmission ranges. Short transmission ranges. Short transmission ranges. That means few inches to less than 6 feet. Few inches to less than 6 feet. Next, coming to high frequency RFID system. High frequency RFID system. The frequencies range from 3 MHz to 30 MHz range. Particular typical frequency is 13.56 MHz. The standard range is anywhere from few inches to several feet. The transmission range is from few inches to several feet. Third one is UHF RFID system. Ultra high frequency RFID system. 300 MHz to 960 MHz. Typical frequency is 433 MHz. The transmission range is from 25 plus 25 plus feet away. Next one, last one is if the longer ranges are needed, using tags with additional power can boost read ranges to 300 plus feet. That is very important point. If longer read ranges are needed, using tags with additional power can boost read ranges to plus feet. Coming to advantages. Data can be collected without human inference. First one, data can be collected without human inference. RFID offers better operation than barcode. RFID offers better operation than barcode, because RFID doesn't require any line of sight communication. In case of barcodes, some black and white vertical lines are there. The operation is totally depends on line of sight communication. Such type of communication is not required in RFID technology. Can identify individual objects without a direct line of sight. That is very, very important. Data can be updated in real time. Data can be updated in real time. Multiple tags can be connected to the radar in order to have a simultaneous operation. We have multiple tags. One single radar is there. These multiple tags are exposed from these single radar simultaneously. Multiple tags can be connected to the radar in order to have simultaneous operation. Tags show less sensitivity towards chemical and physical changes. Tags show less sensitivity towards chemical and physical changes. Physical changes. These are the some advantages. Coming to disadvantages, the implementation is very costly compared to barcodes. The cost of the RFID system varies according to the application. The cost of the RFID system varies according to the application. Second one, suppose multiple tags are simultaneously read, means some collision is there. That is the disadvantage. Connecting multiple tags to a single radar may lead to cause some collisions. Between them, resultantly causing a loss of data. Causing a loss of data. Unauthorized, sometimes tag information is available, and unauthorized person will come and just read the tag information by using radar. That is also a disadvantage. Unauthorized person unauthorized access to the tag can lead, not read, can lead to privacy issues, and their encryption, and thus encryption is necessary. Data is transmitted into the RFID data base where it can be stored and evaluated. That is another important. Last one is a computer system. The data is transmitted into the RFID database where it can stored and evaluated. Next one, RFID applications. RFID applications. Inventory control. SS tracking and equipment tracking. Pet means animals, and live stock tracking. Cargo and supply chain logistics. Supply chain logistics. Vehicle tracking. Vehicle tracking and shipping healthcare. Shipping healthcare. Manufacturing units or manufacturing. Retail sales. Coming to healthcare, wristbands are attached to patient. That information is inbuilt with that wristwatches. Patient name, patient age, patient blood group. What are the drawbacks? Patient total complete patient information is incorporated with that tags. Therefore, that tags, doctor read that information from these tags only, give some prescription to the patients. Tests results are also incorporated with the tags. These are some important applications related to RFID technology.